If you use an iPhone, chances are you've tried this beauty app called Shazam. Shazam feels like magic. When you play a song in front of it, it knows the name of that song. To understand how this works, let's first take a look at the Fourier series, which shows how a periodic function could be expressed as an infinite sum of sine and cosine functions of increasing frequencies. This process is represented mathematically as shown. The Fourier series works like a filter that allows us to work out how much of each ingredient we need to make up a specific function f of x. The more sinusoidal functions we include, the closer the approximation is. The most important parts of the Fourier series are those coefficients ak and bk. Similar to how a vector could be decomposed into two perpendicular vectors using projection, those coefficients are computed by normalizing the inner product in Hilbert space between f of x and a sinusoidal function of a specific frequency. Using Euler's formula, we're able to write the Fourier series in its complex exponential form. The magnitude and phase information of the sinusoidal function is stored within a complex coefficient ck. When we extract ck into its own function and extend its domain to all real numbers, we get the Fourier transform of the function in terms of the frequency omega. This function is paired with the inverse Fourier transform function to form a unitary Fourier transform pair. The negative sign in the exponent comes from the complex conjugate part of the inner product. Back to Shazam. Since the audio recorded by the microphone contains discrete data points sampled at a small constant interval, the discrete Fourier transform is used. DFT involves the multiplication of large matrices. To reduce its computational complexity, fast Fourier transform algorithms were invented. Shazam applies the Gabor transform to the song, which uses a sweeping section of the Gaussian function as a window function before applying a whole bunch of fast Fourier transforms in order to obtain a spectrogram. Under the hood, Shazam searches for the key features of this spectrogram in its database, and this song happens to be Rick Astley's Never Gonna Give You Up. Thanks for watching.